So what I want to talk about here is reinforce some stuff from last week and then start answering a couple of questions that came up that people had from the document that we created on Tuesday of last week. So first, I just want to really emphasize what it means for an object to be positive, negative, and neutral. So what I have here is a field of quarters. Right, you can see the quarters underneath there. And on top of each quarter is a penny. And what I'd like you to imagine is that this is what a solid looks like when you zoom into the atomic level. A solid, you may have learned last year in chemistry, is a series of atoms arrayed in a pattern. And that pattern is called a crystal lattice. And every solid is made up of a crystal lattice. And so you can think of each of these quarters as a nucleus or a proton if you just want to keep it nice and simple, right? And so the solid is made up of a structure of these. Now, this would be a cubic lattice because of the square nature of the organization, but it doesn't have to be. It could be in triangles, it could be in hexagons. There's all sorts of different structures that various elements are made out of. But we're not going to get too much into that. I just wanted to say that. So right now what we see is that for every proton here, for every quarter, there is an electron partner, right? So the charge on a proton is plus 1e, the charge on an electron is minus 1e. And so what we're seeing here is a representation of what a neutral object would look like, right? It's not that it doesn't have positives, and it's not that it doesn't have negatives, but it's an equal amount. Now, obviously, the electron wouldn't be on top of the nucleus, it would be orbiting around it, and these things would be spaced a lot more so that there was space to orbit. And this is not to scale because the electron would be smaller than the nucleus, right? But it's just to give us a visualization. So then, what I want to talk about here is what it really means to be charged, because that's going to help us out. So if I were to come along here and somehow grab off one, two, three, 4, 5 of the pennies, right? So now we would say that this object would be charged how? Hopefully you said positive, because right now it has more of the positives than it does the negatives, right? This would have a net charge of, well, it lost 5 electrons. So it would have a charge of 5e is the way that we say that. It is missing 5 electrons. Now, here's the thing though. If this is what was happening, this is not what the organizational structure would look like, because right now there's a lot of electrons here and they're all repelling each other, right? And these protons are attracting the electrons. Right now there's this concentration of missing negative. So if this object was a conductor, what would happen is the electrons would try to reorganize themselves to sort of distribute the excess charge. So maybe that one might move there, and these kind of like would move there, and then there, and then that might move like here and here and here and here, right? This one might move such that, that would move over to here, and then this to here, so on and so forth, just to distribute where the excess charge is. Let me just do that. So right now it's still the same, missing the same number of electrons, but what's happening here is that the electrons are trying to distribute themselves in order to minimize the repulsion between them, right? So you end up with certain places where the charge will be missing rather than others. And that's what's happening on a device, because electrons are always going to move from places of higher electron concentration to lower electron concentration if they have the choice. You can kind of think of it as like electrons are the original social distancers, right? They always want to maintain as much space between them as they can. And then when they get, when you get too tightly packed, what happens if some other space becomes available that they can move to, they'll move to that. So I want you to keep that in mind as we go through this, because what I want to describe to you is something that's called charging by conduction. So far we've looked at one way for an object to become charged, and that was taking two neutral objects like, I don't know, a piece of plastic and a piece of fur that are both neutral initially and rubbing them together, and then voila, we found out that the rubber became negative and the fur became positive. And in that interaction, if the rod became negative, electrons must have gone from the fur to the rod. So this thing lost electrons to become positive, and this thing gained electrons to become negative. Okay? Now, why does that happen? Well, that just happens so that this material in that interaction attracts electrons more strongly than this material does, forcing some of the electrons over, right? So using chemistry terms, the stuff this is made out of is more electronegative than this stuff. But what I can do with also is, if I have one charged object and one neutral object, I can do something called charging by conduction, which is a little different than charging by friction, but the same idea. But let's say I have that negative green rod. So it has negative, an excess of electrons that got on there because maybe I rubbed it with a piece of fur. And let's say that I had a sphere originally. Now this sphere is originally neutral, we'll say, so I'll just draw a little N there for neutral. Now, if this green rod is brought in contact with the sphere, what's going to happen here is that these electrons are all really tightly packed in here, all the excess electrons. But here, the neutral object has an equal number of negatives and positives. And so what's going to happen here is the electrons are going to move from a region of high electron concentration to the region of lower electron concentration. So electrons are going to transfer over in this process, right? So this device is going to become less negative, the rod, but my sphere becomes more negative. And so electrons are going to transfer until there's an equal distribution of charge on these. Now, notice I didn't say an equal amount of charge. It's an equal distribution of charge, right? Until they all feel that they can social distance appropriately, okay? Now, if I did this with a positively charged thing, right? So let's say it's a glass rod. So this thing has missing electrons, right? A lack of electrons. I have a neutral object there, and I bring them in contact. Which is the object with the greater electron concentration now? Well, it's actually the neutral object, right? Because this thing is lacking electrons and wants to get back towards equilibrium, back towards neutrality. So it's going to pull excess electrons here, because the electrons here are saying like, hey, there's more space over here. It's like when you're in a crowded subway and you notice the next car over is almost empty, and so you're like, oh, okay, well, when the doors open, I'm just going to go over into the next car. And people do that. People want to space themselves out, and so what happens is this thing becomes less positive because it gains some electrons, and this becomes more positive. Now, you may note one thing that I'm doing here is that on the rod, the plastic rod and the glass rod, I'm drawing the excess charge inside, and on the metal sphere, I'm drawing on the outside. Remember, we learned in the last video that on a conducting device, excess charge always resides on the outside surface because it can move, and on a insulating device, because both plastic and glass are insulating, that charge is not very free to move. So what ends up happening is wherever that charge got placed on it, say when it got charged by friction, that's kind of where that charge stays. And so it could just stay in one part, the excess charge in one part of the object. So this is charging by conduction. Notice here, I take one charged object and one neutral, and what ends up happening is at the end of this process, both objects end up having the same flavor of charge as what charged them. So when you take a negative object and charge a neutral object by conduction, you end up with two negative objects. When you take a positive object and you charge something by conduction, you end up with two positive objects. And that's the way that charging by conduction works. So in this next video, we're going to learn why neutral objects are attracted to all charged objects.